All right, next problem is going to be for Charles' law. Charles' law is going to involve temperature and pressures, or volume and temperature. Apologize. Volume and temperature. So in this problem here, we are given a volume, so volume of air of 40 milliliters, and a temperature of 30 Celsius. We're given a new temperature, 20 Celsius, and we're asked to find what's the new volume. So we have volume 1, temperature 1, temperature 2, and volume 2 is what we're looking for. So volume 1, temperature 1, volume 2, temperature 2. So to solve for this, we're going to plug in what we know. So volume 1 is 40 milliliters. Temperature 1 is 30 degrees Celsius. Our temperature 2 is going to be 20 degrees Celsius. And our volume 2, we don't know what it is. That's the new volume. All right, if we were to solve for this right now, we'd get it wrong because this is in Celsius. So we need to add 273 to all of these temperature readings to give us Kelvin. So if we add 273, we're going to get 303 Kelvin, and we're going to get 293 Kelvin for the new temperature. So we need to use these values. If you use Celsius, you'll get it wrong. All right, let's look at our equation. For Charles' law is this one, V1T2 equals V2T1. So V1T2 equals V2T1. So to solve for this one, we're going to plug in what we know. Our V1 is 40 times our T2, which is 293. And that's going to be equal to our volume 2, V2, times our T1, which was 303. All right, so we can solve for V2. So we're just going to divide both sides by this. We can multiply this first and then divide. So let's just do that. So 40 times 293 would give us 11,720 equals our V2 times 303. So we need to just divide both sides by 303. I already have this number in my calculator, so I'm just going to divide this by 303. And we're going to get an answer of V2 is 38.68 milliliters. We check our unit, milliliters. So we see that it goes down by a little bit. If you had used Celsius, you would have gotten a lot bigger of a change.